To find eigenvectors, A minus lambda I x equals 0. See, we have used this A minus lambda I x equals 0. So lambda equals 2. We'll have to use first eigenvalue. Lambda equals 2. Substitute in this equation A minus lambda. See here, A minus lambda I x equals 0. This is your A minus lambda I. This is your x, which is equal to 0. Now you substitute lambda equals 2 here. You will get 1 minus lambda. So you will get minus 1. So this one is here, minus 2. 4 minus lambda, you will get 2. So x1, x2. You just simplify. You will get minus x1 plus x2 equals 0. Just do the operation, you will get minus 2x1 plus 2x2 equal to 0. From the first equation, you can get x1 equals x2. If x1 equals 1, x2 will be 1. Very simple idea. If x1 equal to 1, x2 must be equal to 1. So your x1, x2, 1 comma 1, as I said, you will have to write in terms of column vector. Can you remember? So as I said earlier. So you have to write the eigenvectors in terms of column vectors. So we have written 1, 1. Is it okay? Now use another eigenvalue in the same formula, A minus lambda I x equals 0. So A minus lambda I x, which is equal to 0. Now you substitute lambda equals 3 here. You will get 1 minus 3, which is equal to minus 2. 1 minus 2, 4 minus 3 will give you 1. x1, x2. Simplify. You will get in terms of some equation minus 2x1 plus x2 minus 2x1 plus x2 equal to 0. It says that minus 2x1 equals minus x2, so 2x1 equals x2. You substitute x1 equal to 1. You will get x2 as 2. Just substitute x1 equal to 1. You will get x2 as 2. So you will have x1, x2 as 1 by 2. You will have to combine this one and this one to form P. This is the third step is. Third step. So first step is you have to find out the eigenvalue. Second step is you have to find the eigenvectors. Make it into column vectors. Very important. Make it into column vectors. See here. And as I said, you have to form P. See, P becomes 1, 1, 1, 2 using eigenvectors. Is it okay? We have found out two eigenvectors. You have to form P matrix. P is nothing but the first eigenvector, and this will be the second eigenvector in terms of column vectors. Is it okay? Now, what of D? D is, these are all eigenvalues. 2, 0, 0, 3. 2 is the eigenvalue. 3 is also eigenvalue, which we have obtained earlier. Okay, now we will find out now P inverse. We will find out P inverse. What is the formula? P inverse equals HA by A. HA is nothing but the transpose of the cofactor. HA. So we will have to find out now P inverse. 1 by det P. So that will give you 1 by 1. So det P equals 1. So this will be your half an hour. So this will be your P inverse, which is equal to 1 by 1, 2 minus 1 minus 1, 1. So we will get 2 minus 1 minus 1, 1. So this is your P inverse. We have used HA by det A. Det A is nothing but 1. So 1 by 1. Okay. HA is nothing but cofactor of transpose of the cofactor. What is the cofactor of 1? 2. See, we are written 2 here. What is the cofactor of 1? 1. See, minus 1. What is the cofactor of 1? Minus 1. See, minus 1. What is the cofactor of 2? 1. See, we are written 2. 1. You just transpose. That will give you again the same. See, 2 minus 1 minus 1, 1. You will get this. So this is your P inverse. PA P inverse. You find out PA P inverse. So this is your P. This is your P. This is your A, original A matrix, and this will be your P inverse. You simplify. You will get 1, 1 minus 2, 4, which is nothing but your A. A vector is nothing but 1, 1 minus 2, 4. So PA P inverse you will get as A. This is also another method, another idea about diagonalization matrix. PA P inverse will give you A. So D is nothing but P inverse AP. We are going to now diagonalize the matrix. The formula for diagonalizing the matrix is nothing but P inverse AP. So P inverse is here, A is here, P is here. P inverse A, P. So you just multiply this one, matrix multiplication, you will get this, matrix multiplication you will get, so you will get a D as 2003, which is nothing but your eigenvalues of the matrix. See here, thus we have diagonalized the matrix. This is the procedure. This process is known as diagonalizing the matrix, and this is useful for finding the powers of the matrix. Okay. So what are the steps? The first step will be you have to find out the eigenvalue. Second one will be eigenvectors. You have to make these eigenvectors into column vectors, and you combine these two will get you P vector. So P vector or P matrix. Then after that you have to find out P inverse. You have to find out P inverse. P inverse AP will give you A. That and all P inverse at G, that and all calculation. You will have to do. So that's the idea behind the diagonalizing the matrix. Now this is your assignment, one page assignment. I have given answer fully. You will have to fill up all in between steps. See, answers are given. Okay, you will have to fill up all your in between steps. You will have to fill up. A is a similar to the diagonal matrix D, which has diagonal elements. So now A matrix is given. Okay, eigenvalues are given. You have lambda 1, 2, lambda 2 equals minus 1. So eigenvalues are 2 minus 1. Eigenvalues are nothing but 2 minus 1. You will have to find out how to find out eigenvalues using A minus lambda I equals 0. You will get 2 and minus 1. Then A minus lambda I multiplied by x equal to 0. You will have to find out eigenvectors. So these are all eigenvectors. You will have to find out. Answers are given. You will have to find out the steps. That's your assignment. So this is your eigenvectors. Combine these two will give you P matrix. See, P matrix. P inverse AP will give you this. Exactly 2, 0, 0 minus 1, which are nothing but diagonal elements. Diagonal elements are nothing but eigenvalues. So this is your assignment. You will have to fill up all the steps in between. Now we will go for 3 by 3 matrix. The same technique we are going to use. Now 3 by 3 matrix. So A is given as this. So as usual, we will have to find out the characteristic equation. Use this formula. Lambda cube minus S1 lambda square plus S2 lambda minus S3 equals 0. S1 is nothing but sum of the diagonal elements. 2 plus 1 minus 1 equals 2. So you have S1 is nothing but 2. S2 is nothing but sum of the minor diagonal elements. Sum of the minor diagonal elements. We have this plus will give you minus 5. So S2, we have obtained S2 now. Now S3 is nothing but det A, which is nothing but det A, determinant of A. You will get exactly S3 as minus 6. The characteristic equation is given as lambda cube minus S1. S1 we have obtained as 2, correct? S1 we have obtained as 2. So S2 is nothing but minus 5. S3 is nothing but minus 6. You substitute here, you will get the characteristic equation of the given matrix. Now we will have to factorize. This is in terms of cube. We will have to factorize now. So we have the technique, which is nothing but 1 minus 2 minus 5, 6. As usual, you will have to go with 1. So you will get 1 multiplied 1 will give you 1. You subtract minus 1. 1 multiplied minus 1 will give you minus 1. You will get minus 6. 1 multiplied minus 6 will give you minus 6. So 1 will be one of the factors. Okay. So you will get lambda minus 1 equals 0. Lambda minus 1 equals 0. So lambda equals 1. Because we have obtained only 0 here. That's the reason. So now remaining term will be lambda squared minus lambda minus 6 equal to 0. So now you will have to factorize this. You will have to factorize. Factorizing, you will get lambda minus 3, lambda plus 2. So eigenvalues are 1, minus 2, 3. Is it okay? So eigenvalues are this. Then another technique another technique is you just add all the eigenvalues. Just add all the eigenvalues. Another idea, 1 minus 2 plus 3 which is equal to 2, which is the sum of diagonal elements. S1. What is sum of diagonal elements? 2. You add all the diagonal elements, you will also get 2. This is another idea. Multiply all the eigenvalues. This is first eigenvalue, second eigenvalue, third eigenvalue, which is nothing but minus 6. That is the answer for your det. See, this is another idea. Det. What is det? The value of det is S3 minus 6. See, you can check in between, you can check whether you have done correctly or not. Now we have to go only with the eigenvectors. For the eigenvectors, we have to use this formula, A minus lambda I x equals 0. So your A minus lambda I x which is equal to 0. So 3 by 3 matrix, you have to have only 3 equations, 3 polynomials. So as usual, you have to have matrix operation. You will get the first equation exactly like this, second equation like this, and third equation is like this. Okay, very simple one. 2 minus lambda multiplied by x1 minus 2 multiplied by x2 plus 3 multiplied by x3. Similarly, you can go for the second row, third row, you will get all the 3 equations. Now case 1. Case 1 is when lambda equals 1. When lambda equals 1, this is the characteristic equation, 2 minus lambda, that will give you 1. So 1x1 minus 2x2 plus x3 equals 0. The second equation becomes 1 minus lambda. So 1 minus 1 lambda is 0. And third one is minus 2x3 equals 0. So now you have to solve to get eigenvectors. So as usual, you write x, y, z here. You start from second term, minus 2, 3, 1, minus 2. The second one will be 0, 1, 1, 0, where x will be minus 2 multiplied by 1. So x by 2, x by minus 2. And similarly, x2 by 2, x3 by 2. So common terms are there. So you can go with dividing by 2, it will give you x1 by minus 1, x2 by 1, x3 by 1. So x1 is minus 1, 1. It is in terms of rows. You have to write in terms of columns. Don't forget. Okay, so that's the idea. So now we have found out for the first eigenvalue, we have found out eigenvector for the first eigenvector. Similarly, we can go for case 2. Case 2 will be use the same characteristic equation. When lambda equals 3, those equations will become exactly like this. You have to find out now x, y, z values. So x, y, z, write minus 2 first, 3, minus 1, minus 2. Similarly, you can write this. You can get the x value as multiplying this minus this. You will get x divided by minus 2 plus 6. x2 divided by 3 plus 1. x3 divided by 2 plus 2. You will get x1 by 4, x2 by 4, x3 by 4. Common terms you pull it out. So that will give you 1, 1, 1. So we have found out the second eigenvectors. The third one, lambda equals minus 2. Use the same characteristic equation. Use lambda equals minus 2. You will get this. Okay, 3 equations. As usual, you will have to find out the values of x1, x2, x3. And we are going to solve. So x, y, z becomes minus 2, see, minus 2, 3, 4, minus 2. Minus 2, 3, 4, minus 2. So 3, 1, 1, 3. You will get x1 divided by minus 2, minus 9. x2 by 3, minus 4. x3 by 12 plus 2. 12 plus 2. So here, x1 by minus 11. x2 by minus 1. x3 by 14. There are no common terms. See, there is no common term here. You have to write as it is. So earlier, see here, there were common terms. Okay, we can divide easily. Now there are no common terms here. There is no common term here. So we can't do anything. As it is, we can write. One can simplify as, you can write this as plus 11 plus 1 minus 14. Answer is the same. Instead of going for 2 minus, you can write that minus 2, that term. Answer will be the same. We are going to do the same thing. You can also write. Or else you can write as it is. Doesn't matter. You will get both the answers same. So 11, 1 minus 14. Okay, now these are all your eigenvectors. Very good. These are all your eigenvectors. You have to make it into column vectors to get P matrix. Your P matrix is this one. See here, minus 1, minus 1, 1, 1, minus 1, 1, 1. See, eigenvectors. Second one is 1, 1, 1. Third one is, see, minus 11. So I have written as 11, 1, minus 14. So this is your P. Another idea is, I'll say a little bit later. So we'll find out AP. So A is given as in your problem and P is here. So AP. A multiplied by P will give you this matrix, AP. Okay. What is P inverse? We know already, adj P divided by mod A. What is adj P? Transpose of a cofactor. Okay. So you have to find out now first determinant of P. So this determinant of P is given as this. So you will get the answer as 30. So det P is nothing but 30. Adj P, we are going to find out adj P. Adj P is nothing but your transpose of a cofactor of the main diagonal elements. Correct? Is it okay? Transpose of a cofactor alone. So what is minus C? What is a cofactor of minus 1? 1 multiplied by minus 14, minus 1. So answer is minus 15. Is it okay? What is the cofactor of 1? 1 multiplied by minus 14, minus 1. See? 1 minus is there already. So you will have 15. What is the cofactor of 11? 0. 0. See, 0 is there. Is it okay? Now you have to take the transpose. When you are going to take the transpose, rows into column, column into rows, that will give you this. Any doubt? So adj P is over now. P inverse equals adj P divided by det A will give you this. Your D is P inverse AP. We have found out AP just now. Can you remember? AP is here. We have found out just now AP. So your P inverse AP. P inverse is here. Your AP is here. You are going to have the matrix multiplication. And you will have 30, 0, 0, 0, 90, 0, 0, 0, minus 60. So that will become 1 by 30. You have to just bring 1 by 30 inside. Will give you 1, 3, minus 2. Which are the eigenvalues? All the diagonal elements are eigenvalues of the original matrix which we obtained earlier. See? Okay, hence it is proved. Now again, this is your assignment. This is part 3 by 3 matrix. Answers are given. You have to fill up your steps in between as usual. So A is given as this. Okay, A is given as this. And what of your characteristic equation? So that will become lambda minus 1, lambda plus 2 whole square. See here. Lambda is minus 2 as well minus 2. 2 are there. See here. Lambda plus 2 whole square. Okay. You'll have to write lambda equals 1, lambda equals minus 2, another lambda is minus 2. What are the eigenvectors? For lambda equals 1, you will get this. For lambda equal to minus 2, you will get another one. Lambda equal to minus 2, you will get another eigenvectors. So there are 3 eigenvectors. Just check. Okay. So now we have to write all the eigenvectors into column vectors to have P matrix. Okay, P matrix. Now, this is another one. We know that D equals P inverse AP, correct? I am going to multiply on both sides by P. See, we know the formula for diagonalization matrix. D equals P inverse AP. Multiply on both sides by P. So that will give me dP equals P inverse will cancel. You will have AP. So dP equals AP. Okay, we are going to multiply AP, you will get some answer. When you are going to multiply dP, you will get the same answer. That's the idea. This is another idea. So instead of going for P inverse, you can also do like this way. This is another idea. Okay, P inverse is a lengthier one. Instead of going for P inverse, you can also do the same thing. You will get the same answer. So now let us find out. AP is given us. So AP. So A matrix is here. Your P matrix is here. So AP is given as this. You find out dP. D is here. P is here. you find out dp. See, both the matrices are the same. Okay, this is another idea. Okay, so in this class we discussed so many things on matrices, especially on Cayley Hamilton theorem and the diagonalization of the matrix. Cayley Hamilton theorem, out of which we can learn the powers of the matrix. Any power we can obtain using this, and also A inverse. Diagonalization matrix, we can get the diagonal elements. These diagonal elements are eigenvalues of the matrix. So eigenvalues will be always written in terms of diagonal elements in a matrix. Okay, so that is the end of unit 3. Okay, we'll see in the next class. Bye, students.